I'm recording. And give me a moment, ma'am.
Just give me a notification when I have to start, sir.
Ma'am, now we can start. Now you can
Yeah.
start, ma'am, because I'm going live on YouTube.
Okay, I'll start now.
Yes,
Thank
ma'am,
you.
please.
A very good evening to one and all present. Am I audible, Jabba, sir?
Yes, ma'am. Yes.
Okay. Research is formalized curiosity. It is poking and prying with a purpose by Zora. So, yes, we are all gathered here for a new learning about our research process. A very good evening to one and all present. It takes immense pleasure in welcoming you all for this wonderful webinar conducted by the University of Madras and Madras University Commerce Alumni Association in collaboration with Sri Shankarlal Sundarbai Sachin Jain College for Women. I feel honored in welcoming the convener, Dr. R. Shanti Ma'am, Professor and Head, Department of Commerce, University of Madras, Program Directors, Dr. A.G. Vijayanarayanan Sir, Assistant Professor, Aided PG and Research Department of Commerce, DG Vaishnav College, Dr. Haridayal Sharma Sir, Assistant Professor, Aided PG and Research Department of Commerce, DG Vaishnav College, and Dr. A.S. Nagalatha Ma'am, Assistant Professor, Aided Research Supervisor and Guide, Department of Commerce, C. Kandasami Naidu College. I would also like to extend a warm welcome to Dr. X. Batmavati Ma'am, Principal, Sri Shankarlal Sundarbai Sachin Jain College, Dr. S. Rukmani Ma'am, Vice Principal, Sri Shankarlal Sundarbai Sachin Jain College. We also welcome our organizing committee members, Dr. C.K. Deepa Ma'am, Associate Professor and Head, PG and Research Department of Commerce, Sri Shankarlal Sundarbai Sachin Jain College, and Mr. Jabba Samuel, Full-Time Research Scholar, University of Madras. Let me now introduce our esteemed resource persons of the day, Dr. A.G. Vijayanarayanan Sir. He is an esteemed assistant professor in the PG and Research Department of Commerce at DG Vaishnav College. He holds a doctorate in commerce alongside notable qualifications such as MCom, Net and Set in Commerce, Set in Management, and a postgraduate diploma in software based statistical analysis. With over 7 years of distinguished teaching experience across reputed institutions like CMR Center for Business Studies, Cambridge Institute of Technology, Patrician College of Arts and Science, and Wales Institute of Technology and Advanced Studies, WISTAS, he has significantly contributed to the commerce education. He is an accomplished researcher with 8 published research papers exploring topics such as impact of COVID-19 on consumer behavior, occupational stress, and marketing strategies. He is frequently invited as a resource person to deliver expertise on diverse subjects, including research ethics, data analytics, and operations research. He, as a lifetime member of reputed professional organizations such as the Indian Commerce Association and the Indian Accounting Association, and a fellow member of the Indian Commerce Association also. Dr. Vijayanarayanan Sir holds key positions as a doctoral committee member at SRM Institute of Science and Technology, Chennai, and Garden City University at Bengaluru. His unwavering dedication to academia and research continues to inspire and advance the scholarly domain. Next, we have our dear Dr. A.S. Nagalatha Ma'am. She is an assistant professor in the Department of Commerce at Sri Kandasami Naidu College for Men. She holds PhD from the University of Madras along with MPhil, MCom, and NET qualifications. With over 20 years of teaching experience at the undergraduate level and 18 years at the postgraduate level, she has guided 8 MPhil scholars and currently she supervises 6 PhD candidates, of whom one has been awarded a PhD, one has submitted a thesis, and 4 have submitted their synopsis. And the topic for today is about sampling techniques. Now over to the resource people.
Thank you so much. Hope I'm audible.
Yes, sir.
Yeah, thank you. So, good evening, everyone. So, this is Dr. Vijayanarayanan. So, today's topic is about sampling methods. A very, very important, which is basically, I would say, the crux of any primary data research, I would say, because if you attend any of the Vivavas examination for PhD or for at any level, the major questions by the examiner and the audience will revolve around sampling method, sample size, and so on and so forth. Okay, so we'll start the session uh, with just thanking our gurus. Next slide, ma'am. So we thank our guru, Dr. M.V. Arlalan, who's my guide and alma mater, and his guru, Dr. Ranganathan sir, and his guru, Dr. O.R. Krishnaswamy sir. And also, we would like to thank Shanti ma'am, head of the Department of Commerce, University of Madras, for giving us the great opportunity to explore on the set topic. And I also like to acknowledge some of the websites which I have referred for today's session. So, with this brief acknowledgement, I would like to go to today's topic. See, today's topic revolves around
Sampling
sampling
method.
method. Yeah. So, in sampling methods, we have divided this into two. One is the sampling methods, the other one is sample size, the estimation, sampling errors. So, based on the availability of time, we will see whether we can finish both the topic or we will focus methods today or based on the availability of time. So I would like to extend Nagalata ma'am for the first few slides. Thank you, ma'am.
Thank you, sir.
Ma'am,
Sample, sir.
ma'am,
So,
1 minute,
yes,
ma'am.
sir. Yes.
Ma'am, I asked Preeti to share the slides, ma'am. I have
Yeah.
shared that. So she'll be
Yes.
sharing from her end, ma'am. 1 minute, ma'am. Preeti, are you there?
Yes, sir. She can. She can. Till that, I'll have a greeting of
Yes, ma'am.
my
Sure,
own.
ma'am.
Uh, First and foremost, I pranam. I give my pranams to my gurus. My foremost and excellent guru, Dr. Ranganathan sir, and Dr. R. Shanti madam, head of the department, University of Madras, Department of Commerce. So, because of them, my learning path have enlightened, and I'm here because of them. So, as Sarah said, the first and foremost thing, like sampling. Of course, sample for any descriptive research. Normal social science people will stick into descriptive
Share
research,
பண்றியா, Preeti?
and very few people will go for explorative research. Okay, so in that cases, you should be very clear about your population, your universe, and the sample size. Okay, so here normally we say a sample, it's a sub part of your universe. Okay, and normally universe you should know the entire population, and that you have to draw your own population which is identical for your research study, and from the population you will choose the sample for your convenience based in order to trace out the result for the particular research. Will you go to the third slide, Preeti Rose?
Yeah. Yeah, we have got it, ma'am.
Yes. So sampling method, it is for the empirical study. Normally any first-hand details, or you want to give the opinion of a different people, normally you'll choose the first-hand detail so that you can directly get the people's opinion and you test it and you prove your own hypothesis related to the objective. So normally this is maybe anything of your research platform. It may be a taluk, a district, a city, or village. People who are connected to that. It may be an object sometimes. Okay. So here we say the population. We from the universe we choose the population, and aggregation of all these units are pertaining to the study. So here we say the samples which has been drawn from the population, or maybe it is an representative that we choose in order to justify our research. Okay. See, for example, my topic is about like unorganized women vendors in Chennai. Okay. So normally when you say Chennai, it is a huge population. Normally it is a universe. So in that universe, I'm choosing a women vendors. Okay, so that two women vendors who are unorganized based. Okay, so like that, my unorganized base is my population. So from that population, I choose the representative, or maybe go directly to the people of different marketplace and different area where the lady vendor, women vendor is available, and I'll take an opinion from them. So this is how your entire universe and the population and your samples are sticking on. Sir, you want to give your opinion in this, sir?
Uh, yes. So as ma'am said, for any data, collecting from the entire population may not be possible in all the studies. So majority of the studies will go through the sampling methods, wherein we used to collect the sample which represent the entire population. So how do we do that is the upcoming topic in the next slides. Yes, ma'am, you can proceed, ma'am.
Yes, sir. Go to the next slide. So normally sampling is the process of selecting a representative from the population, and the selected cases may be a location or a people or an object, whatever that you choose. Okay, fine for your state. Here we have advantages and as well as disadvantages connected to this both. Normally advantages, of course, it is feasible if you're going to take a first-hand information, teaching to the people and knowing the detail by from their opinion, from their mouth. Okay, that will be connected to your study, and you can absolutely prove and relate to the details to your research. And of course, it is reduce the cost. You will go directly and you will get the detail. It is cost incurring, but somehow it could reduce to support get a reliable sources and greater accuracy and speed. Of course, if you know your population and you're ready to select your samples or a representative from that, it is a greater accuracy because you get first-hand information. And of course, for any activities that we have disadvantages too, which is connected to that, sometimes the conclusion or not be valid and reliable. For example, if I'm asking a person who is coming out from the metro station, okay, I want to know about his experience on his understanding and his observation in that particular metro ride. Okay, if I choose a person, if he have come only once, if he have experienced only once, okay, in that particular metro train, and I found him for the sample, as to be get my details. For example, I ask him if you have any restrooms in this metro station. Many of them don't know. Many of them don't know because if you have a very first experience, you may not be have a time to look into that aspects and get the detail unless until you are very frequent, or maybe you got experienced, or maybe from word of mouth you know somebody's. Okay, so this is how it may be valid. It could not be valid and reliable because the person don't have complete knowledge about it. So that time the sample may get maybe not a right person to choose my research. So the sample procedure becomes very complicated when it has been ethical based. For example, see, like when I say I'm going to get a sample, my study is about uh, women's alcoholism. Okay, so when I say this particular topic in Chennai city, okay, so take it in that way. It has become very complicated to get a samples. Okay, and of course, it is a kind of ethical issue that I face. And finally, if necessary, like a skill and technique knowledge to be needed in order to choose the right sampling method from the population, in order to it should reduce your cost as well as your time. Sir, your opinion in this, sir?
Definitely, because many a times what happen, the sampling becomes a very unusable sampling because of the wrong choose of samples. Okay, I also want to add one myth here in this. I thought of adding in the next 2 3 slides. So since ma'am is asking my opinion, there is a concept called 1/10 rule. Okay, 1/10 rule, which says that if your population is 100, your sample size should be 10. Okay, So that is a good representation of the population. But this 1/10 need not be a good sample, I would say. For example, let's say if your population is 1 lakh, what is 1/10 of 1 lakh? It is 10,000. Imagine, is it possible for us to collect 10,000 samples? Definitely it is not. Okay. And even if you collect it, how representative it is a question. So greater the sample, greater is the accuracy, is a myth, or which with caveat we have to use it. If the samples are collected from various places, ensuring the representativeness, then that is fine. If not, that is why we say, especially PhD scholars, when you go to data collection, okay, we must be clear about the sampling method that we are deploying in our study, whether you go for a random or a non-random. Who is your target audience that you need to go and collect it? Unless and until the clarity that we have, it will be, the process that we do will be a futile process, or it will be a very fragile one, and that will not yield a good or accurate results that what we expect for. Okay, so that is my opinion on that, ma'am. Thank you, ma'am.
Yes, sir. Next slide, please. Of course, when you say samples, the samples have, it is need to be accessibility. It is also important and should be cost less based off approach. Okay, go to the next slide, Amma.
Yes,
Sampling
ma'am.
is also have go for an expensive, of course. See, when I stay in Chennai, my research is about like people's experience in what we say, bullet trains or some sort of particular what we say, specific area where that particular facility is available in that that place. So it is take time, and as well as it is costly for me to reach there and get the detail. So now we have the other one. It's what is population and what is sample. As already as we say, population is called as a specific parametric, and the sample is then statistics and part of it. Okay, so here we say the population is an entire crowd, where, as Sir said, 1/10 could be the probable one, or maybe justifiable one. But sir, normally the people will say 30% of population is only can be addressed. What is your opinion in that, sir? In
Thirty
the
percentage
research,
of the population. 30% of the population is addressed in the sense.
addressed in the samples, as when we choose the representative. What is your
Okay, so
opinion? You said 1/10,
so
but majority of the people say 30%.
30% should be the sample size, isn't it?
Yes, sir.
Uh, if it is so, it's fine. But I don't think is it possible for I don't know whether it is possible for us to collect 30% of the sample. Now, let's say I'll give some common examples like what we as a commerce process. Most of our research revolves around work-life balance of IT employees. Okay, this is the most I would say. I don't know how many PhD topics have come on that work-life balance of teachers, work-life balance of IT employees. If that is the case, then first of all, we do not know what is the population size of IT employees in Chennai. There is no authenticated data as such or government data as such. Even if that is so, let's say, for example, now the total population of Chennai is 1 crore plus. Okay, assuming that 10 lakhs is 10 lakhs is the total population of IT employees. Assuming that, it's just a crude figure that I'm giving it. Okay, so if that is the case, if 10 lakh is the population of IT employees, then as per your statement, the sample size you say is 30%, which means it should be like 3 lakh. 3 lakh should be the sample size with which we collect the data. But we all know how much data that we collect. Hardly, we collect around 400, 500, 600, or 700, and so on and so forth. Okay, maximum, we may go up to 1,000 or 1,500, not more than that. Because I have not seen any PhD thesis going more than 1,000 or 1,500 sample size. But again, that 1,000 or 1,500 is large enough to represent a population of 10 lakh, because that is as per the sample size estimators we can do it. So 30% sample size, if you can, it's fine. But I think it is highly impossible for any individual researcher to do it, because if it's a government project or something like that, and if you have a mechanism of collecting the data, that's fine. But for an individual, I think 30%, if it is possible for a researcher to collect it, it's fine. But I don't think so. And
Sir,
with
in that,
yeah,
normally, if you have, for example, in particular workplace, there are only 100 employees. We have to get
then
opinion from 100 employees, sir, because
again, see, okay, so if the population is 100, and if is it possible for you to collect from all the 100 people, if it is possible, that's why I'm using the word if it is possible, if it is feasible, then I would say 100 would be better, because if your population is 100, your sample size should be at least 50 or 60, or at least 50 to 60, because lesser the population size, more is the sample size. More is the population size, lesser is the sample size. That is the basic, condition. And with respect to this population and sample, I wanted to add one more point here. See, the population is denoted by the word parameter in statistics. Okay. So population, for example, I say the Chennai population is 1 crore. That's the big N. That big N parameter, that is 1 crore. Okay. And let's say we collect sample around 4,000 or 5,000. That sample that we have collected is small n, that is 4,000 or 5,000. That we call it as a statistic. So this is a very statistical term which is denoted. Parameter denotes population, statistic denotes sample. Okay. Hope everyone would have gone through this multiple regression, right? So in multiple regression, when you do the analysis, you will get the first table as capital R, that is correlation, multiple correlation, and you will get R square, the next column, R square, which is also called as coefficient of determination or the explained variance. And the next one, you will find it as adjusted R square. So I just wanted to touch upon this. Why we have R square and adjusted R square? Can someone say it in chat so that I can proceed further? So that this pause I can utilize. Hope you would have gone through something called as R square and adjusted R square. You know why? There are two terms, R square and adjusted R square. What does it mean? What does it infer? Let me check the chat box, because else it becomes a very monotonous session for both of us. And we just also have to check, sample whether there are 38 population in this group. How many people are responding? That's our sample size, I would say. So our population today is 38, ma'am. Let's see the
okay,
sample.
sir. So how many of them interested to answer?
We need at least some samples. Or at least if you don't have an answer also, that's fine. At least you can say that also, no issues. I don't find any chat as such.
So it's very technical terms, sir. That's the reason the people are.
That's why I said, ma'am, even if you do not know, you can say, okay, I don't know, or something like that. I just wanted to know the presence of the people. That's it, ma'am. I don't want the answer, but at least I need some response so that, I can assure that, people are here. They are not out of the, Okay. Thank you, Charan. All right. Now let me, now we got one sample out of 38 population. That's fine. Now let me say what is R square and adjusted R square. Yes, R square represents coefficient of determination, which means those independent variables, those independent variables, to what extent it influences the dependent variable. That is what is being expressed by R square. And that R square is only for that sample size that you have chosen. For example, I have chosen 783 samples. Okay. So that R square is explaining me the effect of independent variables on the dependent variable with that 783 sample. But what we normally do, after we find the, we do the analysis, we try to generalize our conclusions, isn't it? We try to generalize it. So what we do, the interpretations or the analysis or the findings that we have done for the sample, is being equated to the population. So that adjusted R square is the coefficient of determination of the population, whereas R square is the explained variance of sample. That's why they normally say the difference between R square and adjusted R square should not be more than 5%. If that is so, then your sample is not much adequate, which represents the population. If you see the results, R square and adjusted R square, they'll be almost the same, which means that the sample is good enough in representing the population. That is what it means. So when I come through this parameter and statistic, I always come through that. So I just wanted to touch on that. So that's a statistical way of representing population. Parameter represents, it's a statistical word representing the population, and statistic is the statistical word representing the sample. That is, parameter is big N and sample is small n. Thank you, ma'am.
Thank you, sir. Next slide, please.
So normally we say what is the good characteristics of good sample. Okay. So here we say it must be representative and it must be accuracy. It is precise and persistence must be there, and it should be size measurable. Okay. That is what we will connect it to this. Of course, whatever that population you choose for your research area, your representative, your sample size should have a quality and should give a reference to a particular research, whatever that you do. And absolutely, accuracy speaks about bias. Any research or any sample, it should not bias. Okay, it should free from bias. That normally you should consider. If the people are very biased, then there will be an error in your opinion. Then precision. So precision is something like standard error. The estimation, whatever that you do, it should be precise, or precision must be there. The less in standard error, higher in precision. Of course, and we have discussed the size probably. So here, sir, would like to add some point in this, sir.
Yes, ma'am. So I just like to add a few points to ma'am's, what she has iterated. Representativeness, that is the most important, because the sample size, first of all, a good sample means it should be the best indicator of representativeness. Okay. Now, for example, if you take in this, Nagalatha ma'am represents one college, I represent one college, Samuel represents University of Madras, and also there are Vijayalakshmi ma'am from Shasan Jain College. So if you see, we represent different. So there are representativeness. But if you take only one organization, okay, then there is no representative. Similarly, when you take up sample for the study that you wanted to, it should reflect the entire population. It is very easy for me to say, but it's a difficult process. It's a complicated process. That is why, first of all, we need to know what our population is, who our population is, what is the population consist of or component of or made of. So that is very important. And the sample that we choose should be representative of the entire population, number one. Number two, accuracy. When I say accuracy, what is accuracy? See, accuracy and precision may look similar. No, but it is not. I'll tell you what is the difference. Accuracy means how close are your sample to the population. How close of the, they say the average sample, the average sample's closeness with the population value. That is accuracy. Precision means that indicates the variability. Precision represents the variability or spread. If you take the sample and do it repeatedly, okay, it should have less variation, it should have more consistency, it should have more reliability. That is what the precision actually means. Okay. And size, obviously, the size of the sample, as I said in my opening remark, more the sample, more is the representativeness, but again, subject to the condition how it is collected. For example, I want to do a study about students' behavior of DG Vaishnav College. Okay, there are 42 departments in my college. Okay, but I am working in commerce department, and the commerce department strength is definitely huge than any other department, and I have the accessibility to get data from my department. So if I collect even 1,000 samples from my own commerce fraternity, okay, our total student population is around 15,000. I guess so. So even if I collect 1,000 from only commerce, the size is bigger. But is it a good sample? Definitely not. Because even though if it is 1,000, it just focus on only one department. It ignores the other department. Therefore, size matters, but subject to the condition, how does it being collected? Matters a lot. Thank you, ma'am.
Thank you, sir. The next slide, ma'am.
Yeah. So I'll touch upon this, ma'am. So this is what I was
Terminology.
I was referring to. Just please go through this. This is not our slide. This is what I have borrowed it from one of the universities, foreign universities, and of course I have given the acknowledgement. So you cannot say I have a plagiarism on a lighter note. So if you see the terminologies of sampling, what is that you are going to generalize? Which population are you going to generalize about? That is the theoretical population that we refer. For example, I was saying about work-life balance of IT employees. So who are the theoretical population here? The people who are working in IT. So in that case, you should exactly define what an IT employee means, because you also have IT, ITES, and so on. Okay. So when we say IT employees, only that is what the population that I am most likely to generalize upon. So that is one. So first you need to know who is your population. Number two, what is the access or the population can you get the access? This is the study population, or this is what which you are going to touch upon, or you have the feasibility of collecting or approaching them and making them a chance of making them as a sample. Okay, then how can you get access to them? That is a sampling frame. Okay, sampling frame is the list of all the population from which you will choose the sample. Okay, for example, I would say all the 42 departments of my of my college students are the population, and they are the study population, and I have the access because now I will request principal, sir, I want to do a study on our students. Okay, so the sampling frame is the students of all the 42. And who is the sample? Not the teachers, but the students, because I'm going to do a study on students' attitude. Okay, so the study unit or the sample unit will be the students of my own college. Okay, that is the sample, because a sample is an undivisible unit. That's why, ma'am, in her opening remarks, she said, it can be geographically present. It can be a unit, like a sampling unit can be an individual or an entity or an organization or anything it can be, depending on what you study. For example, if you want to study about the performance of self-help groups, okay, so the self-help group is the sample. We have, let's say, 1,000 self-help groups. So each self-help group is one sample as such. Okay, thank you. Next slide.
Next slide, sir.
Yeah, so this is what I have been referring. Population, it's a group of individuals, persons, objects, or items from which the samples are taken for measurement. So that is what is that? Who's your target population? And sampling frame is the list of people from which you are going to take the sample. And sampling unit or study unit, okay, they are the people that you are going to choose among or from the sampling frame. You are going to choose it. And sampling fraction is that how many samples are you choosing from the available population. Okay, the ratio of the number of units in the sample to the number of units in the reference population. That's where ma'am was saying a 30%, right? So this is the sampling fraction I was saying about. Okay, and probability sample, we all know probability sampling means every element or every sample in the population will have the equal right of getting selected as a sample. That is probability sample. Non-probability means every sample of the population will not have the equal right of getting selected. For example, now I want to choose 2 people from this 40 participants. So that's a random sampling. But now I restrict, I want to choose 2 men participants. In that case, I forgo or I don't consider the female participants as such. So that's a non-random sampling, because the chance of a female being selected is curtailed by the condition that I put through. Okay, so that is a non-probability sampling. Next, please. You can dwell on this. I will touch upon the probability sampling. We can go with non. You can go with non-probability, ma'am.
Uh, yes, sir. So I will go to the next slide, please. So in this case, sampling method, we have non-probability sampling method and probability sampling method.
Of course, Sarah has given rightly said, like what is probability and what is non-probability. Probability, every chosen samples have given equal opportunity. Okay. Here, non-probability, there is no equal opportunity and equal chances which is given to the selected samples. Okay. This is what normally we say about. So here I'll go with non-probability sampling. If we say sampling frame, the researcher subject to judgmental was to be chosen subject for the sample from the population. See, in a non-probability sampling, there is 4 different sample method. One is purposive, other one is quota, third one is purposive and judgmental goes with simultaneously, and the third one is convenience sampling method. Okay, which will dwell with uh, like easy and sampling method normally we say. So it is about purposive, quota, convenience and snowball sampling method. So these are the 4 different non-random sampling method normally we'll consider in these cases for research. Okay, so here when we speak about non-random sampling method, it is also known as non-random parametric method. Okay, so non-random parametric method where it has not been given proper measures exactly like what parametric has. Okay, so nature of research, it is used for the exploratory research because sometimes the population, sometimes the samples opinion and reaction that you doesn't know. And time and effort, it is very quick and easy because you will not go systematically. It is of course convenience based on your ideology and plan. And we say objective, it is an hypothesis is derived because as we know it is exploratory research, there is a chances of different outcomes. Okay, and next we say the population representation. The population is demographic representation, it is skewed in the sense what as we normally distributed. Okay, that we say it is skewed. And level of bias, of course, when it is non-random sampling, there is a bias, as rightly said by Sir Vijayanarayanan sir. If he choose a sample size from this viewers, 28 participants, only a male. Okay, so he is not getting an opinion from female. It is a biased one. Okay, so this is what my input in random sampling, sir. Sir, please yours.
Yes, ma'am. Yes, ma'am. So now I'll articulate on the random sampling. See, random sampling is also called as probability sampling. We all know. Non-random is called as non-probability sampling. And we all know that random sampling method is more scientific, is what normally they say, because the sample has equal, every sample in the population has an equal opportunity of being selected as a sample. Okay, there are various methods of random sampling methods. I'll touch upon few 4 or 5 methods today, as the time speaks, or as the time is available. Can you just go to the next slide? So the first slide means the first method of random sampling, which I would say is a very simple method. It's called simple random sampling. We normally use this knowingly or unknowingly. Okay, simple random sampling can be used if the population is finite, if the population is countable or very less in number. Okay, So we have lottery method, we have table of random numbers, which we call it as a Tippett's method. Okay. And we have computer generated random number. Okay. So these are some of the methods of simple random sampling through which we can select the sample from the finite or less population. I'll give an example. Maybe I don't know whether the youngsters will know it, but people of my age, I think they will understand. See, in those days when in serials are being shown in Sun TV in the earlier yesteryears, okay, they will ask a question, and we have to write it in postcard and say the answer, and the last 5 minutes will be dedicated for they will that serial heroine or someone will come, and there will be a big box which has all the the answers who the people have posted with the right answer. Okay, some 100 or 200 letters will be there, and she will pick one among that, and she will read out who the winner and what the price and all is about. Okay, so if you say if I can give that as an example for simple random sampling, because the population is very limited, for example 100 or 200. Okay, so you choose one from 100 or 200. So that's an example which I can give it for simple random sampling. Okay, so we have lottery method. We can deliberate this very well, because it has replacement, without replacement, with replacement. We also do this in probability. We learn this in probability. Okay, and table of random numbers. There is a random numbers which is being generated, and we choose the sample based on that. Okay. Next method. See, every method has got its own usage. Okay, so there is nothing like one method is the best and the other methods are waste. No, definitely not. Every method has got its own application, its own uses, its own merits, its own demerits. Okay, so you cannot say one method as the best method, because the sampling method, again we are touching this in the later part of our presentation. The sampling method is based on what kind of a study that you do. Okay, the second random sampling what I wanted to speak is about the systematic random sampling. When I say systematic random sampling, okay, when I say systematic random sampling, a system is being established. Okay, a system or a process is being established. For example, you can see the right side. Totally 1200 is the big N, that is the population size. Okay, now I want 60 samples, that is the N, small n, 60. Okay, so if you see the sampling fraction, that is 20, that is 20% of the total population. Okay, so what I do, I list all the 1200 population from 1 to 1200, and then what I do, I randomly choose between 1 to 20. I choose number 8, that is the 8th sample from 1 to 20, and then n plus 8, that is 8 plus 20, 28, 28 plus 20, 48, 48th sample, 48 plus 20, 68th sample, 68 plus 20, 98th sample. It goes up to 1200, so that I'll get 60 numbers. Okay, so there is a system. Can you just go to the next slide so that you will have an example? Yeah, you see there are 12 people here. I choose the second one, and from there I choose every third element of it. So third and fourth will not come. 5 is chosen. Sample 5 is chosen. 6 and 7 is ignored. 8 is chosen. 9 and 10 is ignored. 11 is chosen. So I choose every third sample. There is a system. Okay, but again it has got its own advantage and disadvantage. So when you number all the population from 1 to last, okay, you should really make it random. If not, again a bias will come in this. So that is one of the disadvantage of this method. The next one, the most common method which majority of the people use it, and even I really like this method personally. This is called stratified random sampling. What is stratified random sampling? The entire population is divided into different strata. And each strata or stratum, okay, are homogeneous in numbers or homogeneous in nature. Okay, and we choose among that. I'll give an example. Can you just go to the see how to do this stratified random sampling method? First, we need to define the population. We need to define the desired sample size. We need to come up with what are the different stratas. But again, having said this, this is most complicated method also. So we must be very careful in choosing the stratums. Okay, and now I'll give an example. What I gave some time back. Now I want to do a study about the students' behavior of my college. I said there are 42 different departments. Okay. So the entire,
Move to the next slide. Next slide,
yeah,
please.
the entire population is the student population of DG Vaishnav College. And now there are 42 strata. What are they? Commerce, psychology, sociology, physics, maths, chemistry, different departments. So I divide each department, or I say each department is one strata or stratum. If you take physics people, they are all homogeneous because they learn physics. If you take commerce people, they are all learning commerce, sociology, defense. Okay. So I divided into 42 departments or 42 different stratas, and from which I choose the sample. So in choosing this, there are two main types of stratified random sampling. You can see this picture here. One is called proportional stratified sampling. You can see in this, the first strata has more people. I think 3, 6, 8, 16 people are in strata 1, which is in red color. And the second strata, which is in blue color, okay, they are around 12 people. Okay, and the third strata people, they are 8 people. Okay, so if you do this, I should not choose equal number of sample. I should not choose equal number of sample. So if there are 8, I am choosing 8 from the first strata and 6 from the second strata and 4 from the third strata. So now this is proportional. For example, commerce strength is around 600, assuming 600. Okay, and physics is around 60 people. Okay, so I cannot choose 10 from BCom and 10 from physics, because BCom has 600 students. If I choose only 10, and if I choose 10 samples from the population of 60, which is in physics, then that is not a proportionate, that is disproportionate. Okay, so proportionally I have to choose it. That's why the first one you can see it's a proportional sampling. Whereas if you don't do like that, and if you give, or if you take equal number of sample from each of the strata, that is called disproportional stratified sampling. I hope I make this clear with this image, I guess so. Okay, so this is about
Yes.
the stratified random sampling. Next one, please. This is again a very nice random sampling, that is cluster random sampling. Here we divide the entire population into different clusters, and from each cluster we choose the sample, similar to what we saw it in stratified random sampling. But I'll tell you what is the difference. In terms of stratified random sampling, please understand, within, I use the word within each strata, the samples are homogeneous. For example, a commerce is a strata, all the people are studying commerce. They are something homogeneous. They are same. They have the same characteristics. Physics, all people are studying physics. So there is a commonality within the strata. Okay. Whereas between the strata, there is a heterogeneity, which means commerce is different, physics is different. Okay. Within they are same, between they are different. But this is exactly opposite in cluster random sampling. Now I'll give one example. Now I want to know, I'll give you one more example for understanding it, cluster random sampling. Now let's say I want to know why people come late to my class. Okay, my students. Okay, if that is the case, then what I do, I ask a question: where do you come from? Some people say they come from North Chennai. Some people say they come from South Chennai. Some people say they come from Central Chennai. Okay, from North Chennai, I have all the students who also come on time, come before the time, and come late to the class. I have all the 3 set of people in North Chennai itself. And in South Chennai also, I have students who are coming before to the class, on time to the class, late to the class. Similarly, with respect to Central Chennai also, I have students from Central Chennai who come before the time to the class, on time to the class, and late to the class. So if you see in this, each cluster, within each cluster, people are heterogeneous. I hope I'm making it very clear. When I say North Chennai, I have all three set of different peoples. One who's coming before the time, two who's coming on the time, three who's coming always late to the class. So within the cluster, there are heterogeneity. But if you see between the clusters, there are homogeneous. So if that is the case, then you can go for cluster random sampling. Next, please. Yeah, can you see this? See, now there are different clusters, and in each of the cluster, you can see there are different people. The people are not same. So within the cluster, they are heterogeneous. And between the cluster, they are homogeneous. Whereas it was opposite for stratified random sampling. So it all depends on what kind of a study that you do, whether to go with stratified or you have to go with the cluster sampling. Okay. Next slide, please. And the next slide is multi-stage random sampling. This is more used for government, decision, policy level decisions. And when the population is really, really widespread, then we can go for multi-stage random sampling. Okay, this is the very most complex random sampling strategy that I would say. I have given one example. You can see it here. Let's say, an administrator want to know all the schools in the district. Okay, so you will start with a cluster. When I say cluster, for example, each district will have government school, private school, CBSE school, matriculation, okay, government aided, okay, because within the district they are heterogeneous, but between the districts they are homogeneous. So that is the first step. What is this multi-stage? You use different random sampling technologies in one study. Okay, application of different random sampling techniques in one study. Then you go with a stratified. After cluster, you want to stratify. Okay, and then you go with simple random sampling, and then you want to choose the sample. So this is what we call it as a multi-stage random sampling, where you deploy all the random sampling methods that you wanted to. And again, it depends on what kind of a study that you do, and whether is it, because see, for doing everything, it involves cost. Because if you want to collect data, it involves time, it involves money, it involves people, resources. Okay, so it's a plenty of action. For example, when you take the census and other things, that takes a real time consuming process. So this is about multi-stage random sampling. So we saw about what is simple random sampling, where we saw lottery method, table of random numbers, and computer generated numbers and all those things. And the second one is about stratified random sampling. The third one is about systematic sampling. The third one was about stratified random sampling. The fourth one was about cluster sampling, and the last one is multi-stage random sampling. Actually, this is not conclusive. We still have much more methods. We will but these are the majorly used methods for our study. So we are focusing on this. The remaining non-random sampling, ma'am will say, and we will take the next component of sample size estimation and sampling errors for the next week. Okay. Yes, ma'am.
Yes, sir. Shall we go to the next slide? Actually, the non-probability sampling is the easiest, normally convenienced or simplest method. Okay, it less involved in cost and time. Now, okay, this is what probably most of the research explorative, it will be connected to this. So when you say judgmental and purposive sampling method, you will define and you will restrict of your own sample size and your own population based on the character. Okay, for example, I'll choose only the business school MBA students. Okay, purposively I'm choosing only business school MBA students in order to know their own, we can say, entrepreneurial skill or interested to become as an entrepreneur. Okay, so this is comes under, because Of course, they have an opportunity and there is a lot of skill-based training they will be given. So I'm purposively want to know how these MBA students can turn into an entrepreneur. So this is an example of purposive and judgmental sampling method where you will be very sure about your research area and you choose restrict your research area in that based on the character. And we so go to the next one, convenience sampling method. More often in most of the research, we can say the YYC, the sampling method, they will say this is the convenience sampling method. And this is, as I told, very simplest and easiest and friendly based method. People can go with personally and as well as with the Google form. They do both in this case of convenience sampling method of choosing the people. Okay, so probably it has a disadvantages too. As I told you the same example, when I am getting a details and opinion of the people experience in the metro station. So one time user has also become my sample and may people have daily experience also become my sample. So this is comes under the case of convenience sampling method. So next slide, sir, ma'am. So when we go for the snowball sampling method, it's very interesting. And of course, this explorative study, it shows a pathway to choose the next sample study area and as well as the sample is representative of my study. See, as I told you earlier session, if I want to study about this the same nature, entrepreneurial skill among transgender. Okay, so like I should be very conscious enough in order to know where the employability skill have been trained or been given opportunity to the transgender people. So from them, I will take a detail of my study and this people and this representatives can show me another platform, another area of study where the same or a different type of entrepreneurial skill given for an other people. So this is one person will take a lead to another person of sample and this sample will give a lead to another person. So how the snow will merged and become as a big role, okay, at the end. So that's kind of, we can say the group of samples will be collected and group of samples will be given me a direction for next lead. So this is comes under snowball sampling method. Quota sampling method. So here stratified sampling based quota sampling method normally which has a little difference where in stratified sample method each and every samples each and everybody given equal opportunity but quota sampling method is not so. Why? Because we are dividing into a different we can say subsets. Okay. For example, as Sarah said, it is the North Chennai or South Chennai and Central Chennai. So I have differentiated the population into a different based on area. Okay. But am I giving an equal chances for all the population or choosing a represent from that population? No. I'm taking as based on my convenience. Okay. So this is comes under the quota sampling basis. So here the non-probability and the probability have only difference where all the respondent, all the population is not given equal chances in non-random sampling. So with this short note, we will end up the session and we thank all the persons who have involved in it, especially my guru, Dr. R. Shanti Madam, and the organizers, and my dear brother, Dr. Vijayanarayanan sir, and another professor, Hidayat Sharma sir, and Triple S Jain College supporters, Madam Principal and Vice Principal, Head of the Department of Commerce, and the team supporters like scholars from Madras University. I thank everyone for giving me this opportunity. I guess the session makes you a better sense towards the sample and the population and your choice and which sample is related to which type of research. So if you have any questions, please share.
Yes. I just like to add one point which came to my mind now. Sorry for taking some time. See, they normally say random sampling is best, non-random sampling is not worth. Right? That's the general tendency. So if you say convenience sampling or judgment sampling, generally they have very, very, they are skeptical about those things. But it is not like that. I was saying random sampling methods are scientific. Okay. Non-random samplings are not unscientific. They are less scientific. They are less scientific. So based on the study and what is the study that you are doing, whether you are going for a random or a non-random is chosen. Okay. For example, if you want to do a study about the issues and challenges or the standard of living of HIV affected people. Okay. Do we have a population size? Definitely not. So what we do is that we will first identify the first person who's affected, who's a victim of it, and then we will know it, and they will know the like people who are affected. They will give us, the reference, okay, from which we will go and collecting. It's a classic example for snowball sampling. Okay, so non-random sampling is not unscientific; it is less scientific. Okay, so it is also one of the method and which can be used provided if it can be. Okay, so we need not ignore non-random sampling is my thought process, but you should take care that your bias is reduced and it has a representativeness. Okay, so that's my point. I conclude with it, and I thank all the organizers who are involved in this. Thank you so much. Any questions we can take for it? I think we don't have any questions.
So normally in Viva Vasi, they will ask like questions. The convenience sampling method is not the right sense of sampling for research.
Exactly, ma'am. That is the reason why I insisted this. See, convenience sampling is not the right method, is not the right answer of, or it's not the right way of question. What your topic is all about, whether your topic needs convenience sampling or not, where the topic can be used the stratified random sampling, and if you unnecessarily go for convenience sampling, yes, the question is right, the question is valid. But if you see again, that's what I said, it depends on what topic that you do. If you are not in a position to know who your population is, what your samples are, where your samples are, how to collect it, if you do not know where to go and approach, then there is no other chance than convenient or purposive or whatever it is. See, I used to say this in my MCOM class. Once I went to Luke's, what is it? There's a mall in Velachery. Okay. A small 15-year-old boy was distributing pamphlets of a real estate advertisement. Okay. He is doing with all purposive sampling, which means he looks at the person from the distance. Okay. The way we have dressed, and then he decides whether to give that pamphlet to him or not. I wanted to get that real estate pamphlet from him. I went very close to him. See, I was wearing a very normal shorts, and I was very very casual. Okay, that guy did not give me. I'm asking, hey, you give me the pamphlet, but he's not saying. Then I asked, why don't you give me? He says, sir, உங்களுக்கு நான் கொடுத்தா வாங்குற மாதிரி தெரியல சார், நீங்களே வீடு வாங்குற மாதிரி இல்லை சார், உங்க மூஞ்சி இல்லை சார். He said like that, which means that he is doing some purposive. He thinks, I don't have the capacity to buy, and he chose not to give that pamphlet to me. Okay, so that's a purposive sampling example, which I always say it in a very funny way. So it depends on what your topic is all about. If you can resort to non-random, or if you don't have a chance for a random sampling, then you can very well resort to non-random. And even in non-random, we have many methods. Okay, there is heterogeneous purposive sampling. There are different methods in that. Okay, so there's nothing wrong in choosing non-random, provided if you don't have a chance to select any of the random sampling, then you can resort to non-random sampling methods is my answer, ma'am. Thank you.
So there's a question in the chat box. Charan
Just a minute. Just a minute. See, study population and sampling frame. That's a beautiful question. See, study population is the entire population that we are intended to study. But sometimes what happens, we may not have access for the entire study population. We may have access to only to certain people from which we can collect the data. Okay, that's called sampling frame. For example, now I'll give an example. You want to do a study about how the government efficiency or the government's efficiency. Okay, so you want to collect from all the government employees how well they are working, how efficient are they. If this is the case, then all the government employees, okay, all the public servants or the population. But in the sampling frame, we can collect it from low level, from mid level, and partially from top level. But can you go and collect it from all the IAs and IFS or IPS? Because it's not possible, because we may not be in a position to reach to them. Accessibility and feasibility is not possible. Okay, so population is, even they are included in that, but sampling frame is the list from which I can collect it. Maybe the very top level officials will not come into that. Okay, so they are excluded from the sampling frame. So that's my point on that question. Thank you so much.
Any more questions from the participants?
Sir, I have a question.
Yes, please.
So we as a researchers, like social science researchers, we always go for this purpose of sampling or snowball sampling or like this one. When should we actually use the simple random sampling, sir? Like the which instances we use the simple random?
Fine. I said in the beginning, you can use simple random sampling provided if the population is finite and if it is within countable. For example, you want to do a study about teachers' effectiveness or non-teaching people's effectiveness of the University of Madras. So, if you take the population of non-teaching people of University of Madras, it is very finite, right? It is hardly less than 500, I guess so.
Yes, sir.
Right? So the population is finite. So the entire population itself is only 500. I'm saying at a very larger number, but I don't think we have 500 people. So if that is the case, then you can resort to the simple random sampling. When the population is finite and very limited, like
In
around
that
100,
case, also
200,
should go
300,
for
then
this
we can go for a
lottery
simple random.
methods, sir. Like
Sorry?
lottery and other methods only should be followed for only for simple random, even if you choose
Most,
that particular
yeah,
respondents.
yeah, it works well in that simple random sampling. The tippet method, the lottery method works well when the population is very finite and limited. It works well. When the population is huge, then that doesn't give the required precision. So simple random is not used when the population is bigger. And there is also a question which I wanted to take it to the next session. When to use random, when to use non-random. Assuming that if you do not know the population size, or if the population is infinite, then what should be the situation? Probably we will answer that in the upcoming session. Just do let us also know about that, so that please remind me about that, so that we can touch upon in the next session
Sure,
when the
sir.
population is unknown or infinite. Thank you so much, ma'am. I hope I have answered your question.
Yes, sir. Yes, sir. Thank you, sir.
Thank you.
Thank you, sir. Any more questions? Participants, if you have any question, you can post in the chat box, or you can even unmute and ask the research questions.
So, Dr. VIJAYANARAYANAN, you were very right when you said the larger the sample, the more accurate.
Yes, ma'am.
You cannot, that is a myth. Many
Yes, ma'am.
people believe that more and more when you collect the data, it is what is a representative that matters rather than this. This
Yes,
is a
ma'am.
myth which is even the guides also follow. I don't know where they got this particular idea.
Yes, ma'am.
Thank
Yes,
you
ma'am.
for, thank you for
Thank you,
opening
ma'am.
up this particular topic, particular
Thank you,
issue.
ma'am.
Yeah. I think we can close. Sam?
Yes, ma'am. Vijay ma'am can proceed with the vote of thanks. Vijay Lakshmi ma'am, are you there?
Yeah. It's my pleasure to propose the vote.
Ma'am, your voice is very low.
Hello. Sir, is it audible now? Hello, sir, is it audible?
Ma'am, your voice is not audible, ma'am.
Now I think she is muted. We can close the session.
Okay. 1 second, ma'am. I'll post a feedback link. I
Sir,
thank
am
all.
I audible now?
Yes, please. Ma'am, you can proceed the vote of thanks.
Please proceed, ma'am.
Gratitude makes sense of our past, brings peace for today, and creates a vision for tomorrow. At the outset, we would like to express a sincere gratitude.
Ma'am, your voice is again gone. We couldn't hear your voice. Akshita, ma'am, your voice is not audible. Okay. Akshita, ma'am. Ma'am, we couldn't hear your voice.
Sir, now is it audible?
Yes, ma'am.
Can I proceed, sir?
Yes, ma'am, please.
A heartfelt thanks to our speakers of the day, Dr. A.G. Vijayanarayanan sir and Dr. A.S. Nagalata ma'am, for spending their valuable time in providing their valuable insights about Robert's research. We also extend our gratitude to our convener, Dr. Shanti ma'am, Professor and Head, Department of Commerce, University of Madras. Program Directors, Dr. A.G. Vijayanarayanan sir, Assistant Professor, AIDET, PG and Research Department of Commerce, Dwarka Das Gavardhana Das, Vaishnav College, Autonomous. Dr. Haridayal Sharma sir, Assistant Professor, PG and Research Department of Commerce, DG Vaishnav College, and Dr. A.S. Nagalata ma'am, Assistant Professor, Research Supervisor and Guide, Department of Commerce, CK Kandasami Naidu College. We would also like to thank Dr. S. Padmavati ma'am, Principal, Sri Shankarlal Sundarbai Shashun Jain College, Dr. S. Rukmani ma'am, Vice Principal, Sri Shankarlal Sundarbai Shashun Jain College for Women, for their unwavering support and guidance. A sincere gratitude to our organizing committee, Dr. C.K. Deepa ma'am, Associate Professor and Head, PG and Research Department of Commerce, Sri Shankarlal Sundarbai Shashun Jain College, and Mr. Jabbar Samuel, Full-Time Research Scholar, University of Madras. Last but not least, I want to thank all the participants for your active participation and cooperation. We request all the participants to kindly fill the feedback form.